This is Chemistry Made Simple YouTube channel. I take this opportunity to once again welcome you to another great learning segment. Our topic of discussion today is nomenclature of halogen hydrocarbons. What is meant by the words halogen hydrocarbons? A simple explanation is that halogen hydrocarbons are hydrocarbons on whose carbon chain there is at least a group 7A element. Mind you, the group 7A elements that are common in this topic are fluorine, chlorine, bromine, and iodine. As a matter of fact, the nomenclature of these group 7A elements is as displayed in the table there. The element fluorine will be named as fluoro. The element bromine will be named as bromo. The element chlorine will be named as chloro. And the element iodine will be named as iodo. This topic is going to be subdivided into 3 parts. In the first part, we shall learn how to name halogenoalkanes. In the second part, we shall learn how to name halogeno-substituted alkenes. And in the last part, which is the third part, we shall learn how to name halogenoalkynes. Note that the nomenclature of halogeno derivatives of benzene has already been covered in the video about nomenclature of benzene and its compounds. Welcome to part 1 of our topic, nomenclature of halogenoalkanes. How do we name halogenoalkanes? In order to name halogenoalkanes, or for that case, halogeno-substituted alkanes, we shall base ourselves on guidelines from Iupac, just like we named other homologous series. The first guideline mandates that you must always locate the parent chain. Please always remember that the parent chain is the longest carbon-to-carbon skeleton in the compound. The second guideline mandates that you assign numbers to the parent chain in a manner that the carbon atoms attached to group 7A elements will have the lowest numbers, or for that case, the lowest locant sum. And this is simply achieved by assigning numbers to carbon atoms of the parent chain by starting from the side or the end of the chain closest to carbon atoms attached to group 7A elements. Guideline number 3 mandates that in case there are more than one similar group 7A elements on the carbon chain, then such a similarity in group 7A elements is indicated by using prefixes di for 2 similar group 7A elements, tri for 3 similar group 7A elements, tetra for 4 similar group 7A elements, and so on, as derived from Latin. And guideline number 4, presence of different group 7A elements along the carbon chain is simply solved by writing the names of the group 7A elements in alphabetical ranking. At this point, we have to practice the above guidelines. Basing on the displayed compound there, our first guideline mandates that we must determine the parent chain. As I have always advised you, The only trick in determining the parent chain is by transversing the compound and determining as many possible as there may be carbon-carbon chains. And of all those possible carbon chains, the chain that has the highest number of carbon atoms corresponds to the parent chain. Now, going back to the displayed compound, the yellow highlighted carbon chain is the parent chain as displayed. Guideline number 2 mandates that we assign numbers to the parent chain such that the group 7A elements will be attached to carbon atoms with the lowest numbers. This will be done or achieved by starting from the right-hand side of the displayed compound. This has been done as displayed there. Notice that the parent chain has 5 carbon atoms, and therefore the parent name is pentane. Also, we do have 3 different group 7A elements, and that is bromo, chloro, and fluoro. In order to write the name of this compound, we must respect the alphabetical arrangement of the 3 different group 7A substituents, and therefore the name of the displayed compound will be 2-bromo 2-chloro 3-difluoropentane, which is simply pronounced as 2-bromo 2-chloro 3-difluoropentane. At this point, I welcome you to the second part of our topic, which is nomenclature of halogeno-substituted alkenes. In order to name halogeno-substituted alkenes, we shall follow Iupac guidelines that have been used in naming general alkenes, but there will be a few changes or considerations. The first guideline is the same and mandates that we must determine the parent chain. Notice that the parent chain in this case must bear the carbon-carbon double bond, in addition to the fact that it is the longest carbon skeleton in the compound. The second guideline mandates that we always assign numbers to the carbon chain starting from the end of the carbon chain that is closest to the carbon-carbon double bond. Guideline number 3 is that presence of similar group 7A elements on the carbon chain of the alkene must be indicated by using prefixes di for 2 similar group 7A elements, tri for 3 similar group 7A elements, tetra for 4 similar group 7A elements, and so on as derived from Latin. And finally, the last guideline is that in case there are different group 7A elements present on the carbon chain of the alkene, then these different group 7A elements must be written in order of their alphabetical superiority. In simple terms, these should be written in alphabetical order. At this point, let us try to practice the above guidelines by using the compound displayed there. Now, the first guideline mandates that we must determine the parent chain. As I have always advised you, when determining the parent chain, always transverse the compound and determine all the possible carbon-carbon connections. And from the possible carbon-carbon connections, the longest carbon connection is the parent chain. Without wasting time, the yellow highlighted carbon chain displayed there is the parent chain. The second guideline mandates that we assign numbers to our parent chain starting from the side or from the end of the chain closest to the carbon-carbon double bond. Without wasting time, we shall number starting from the left end of the carbon chain, and this has been done as displayed there. At this point, notice that we do have a chloro substituent on carbon number 2, a bromo substituent on carbon number 3, and a methyl group on carbon number 5. By writing the different substituents in alphabetical order, then the name is 3-bromo 2-chloro 5-methyl hex 2-ene, and is simply pronounced as 3-bromo 2-chloro 5-methyl hex 2-ene. At this point, I welcome you to the third and last part of our topic, which is nomenclature of halogeno-substituted alkynes. In order to name halogeno-substituted alkynes, we shall follow guidelines from Iupac as follows. Guideline number 1, determine the parent chain in the compound, and in this case, the parent chain must bear the carbon-to-carbon triple bond, in addition to the fact that it is the longest carbon chain in this compound. Guideline number 2 is that we have to assign numbers to carbon atoms on the parent chain by starting from the end or from the side of the chain that is closest to the carbon-carbon triple bond. We shall practice this. Third guideline is that presence of similar group 7A elements on the carbon chain is indicated by using prefixes di for 2 similar group 7A elements, tri for 3 similar group 7A elements, tetra for 4 similar group 7A elements, and so on as derived from Latin. And the fourth guideline mandates that presence of different group 7A elements must be indicated by writing the different group 7A elements in order of their alphabetic ranking. At this point, we have to practice the above guidelines by naming the displayed compound there. Guideline number 1 is that we determine the parent chain on observing the compound. The longest carbon chain in the compound that bears the carbon-carbon triple bond is the yellow highlighted carbon chain. Please always transverse the compound thoroughly and determine the correct parent chain. At this point, we assign numbers to carbon atoms on the parent chain, starting from the side of the chain that is closest to the carbon-carbon triple bond. By referring to our compound, we'll start numbering from the right-hand side as displayed there. Now, notice that on position 4, there is a chloro group and also a methyl group. Therefore, by respecting the alphabetical precedence of each of the two groups, we write the name of the compound as 4-4-methyl-1-1-ine, which is simply pronounced as 4-chloro-4-methyl-1-ine. At this point, I welcome you to our live chemistry classroom, where we shall physically and actively name the given compounds. Welcome to the chemistry classroom. Before us, we do have a question where we are supposed to write down the structural formula of 1,3-dibromo 2-chloro-cyclopent-1-ene. Before we can write down this formula, it is important for us to remember that carbon forms a maximum of 4 covalent bonds. So remember that carbon must form 4 covalent bonds. Now, when we are writing down the structural formula of organic compounds, we always start from the last name, and the last name is the parent name. So when we analyze this, the parent name of this compound is this, that is cyclopent-1-ene. So that is where we are going to start from. Being a cyclic compound, it has a structure that is as displayed here. Now we have to choose any 2 points, and we include our carbon-to-carbon double bond. So what we have written there is our cyclopent-1-ene. Next is that we have to establish position 1, position 3, and position 2. Why those positions? Because those positions have substituents, and specifically group 7A substituents. So when we are assigning the positions 1, 3, and 2 for that case, we always start from our carbon-to-carbon double bond. So without wasting time, this is my position 1, which according to the name must have a bromo group, like that. And this being position 1 implies that this is going to be position 2, which must have a chloro group. And finally, position 3 is here with also another bromo group. As simple as that. Still continuing with our classroom, we have another question here where we are this time naming the compound that has been displayed below. As I have always advised you, whenever you are naming organic compounds, always remember that you must follow guidelines or rules from Iupac. Before we can name our compound, let us first observe it and see if there are any outstanding functional groups. Of course, you have to agree with me that this is a carbon-to-carbon triple bond. This is chloro, this is iodo, this is bromo, and this is bromo. And of course, all of the three are derivatives from group 7A elements. That being said, we now have to execute the first rule of Iupac, which states that we determine the parent chain. And do not forget that the parent chain is always the longest carbon-to-carbon skeleton that is in the compound. But in this specific case, this longest carbon chain must also bear our carbon-to-carbon triple bond. As I have advised you, always transverse the compound, determine all the possible carbon-carbon chains, and the longest becomes the parent chain. Without wasting time, this carbon chain that I have encircled red ink is our parent chain, and by the way, this parent chain has a total of 1, 2, 3, 4, 5, 6, 7, 8, 9 carbon atoms. The next guideline directs us to assign numbers to our parent chain, but we should always start from the end of the chain that is closest to our carbon-carbon triple bond. So also, without wasting time, we shall number starting from this side, and therefore this becomes number 1, this is number 2, number 3, this is number 4, number 5, number 6, number 7, number 8, and number 9. Now notice that the positions number 9, since there is a group 7A element, number 7 also with a methyl substituent, number 5 with a group 7A derivative, number 2 with another group 7A derivative, and number 1 with a group 7A derivative are of interest to us. It is also important for us to notice that we have this one as a substituent, which we called methyl, and then this group 7A substituent, which we simply called bromo, and so is this. And this group 7A substituent, which we called iodo, and finally this group 7A substituent, which we have also called chloro. At this point, we can write down the name of our compound as on position 5 and position 9. We do have two similar groups, and for that case, the prefix di, and then on position 1, we have a chloro group, and on position 2, we have an iodo group. On position 7, we do have a methyl group. At this point, we have been able to write down all the substituents in alphabetical order. So the remaining part, we are going to write down the parent name, which by the way corresponds to a 9-carbon chain alkyne. So the parent name or the parent chain is, and then on position 3, we have our triple bond. As simple as that. For matters of emphasis, I will encircle the obtained name here in blue ink. Do you have any challenging concept as regards organic chemistry? Please do contact me by using the email address in the description of this video, and I will humbly get back to you. Until next time, I remain yours truly, your chemistry teacher. Goodbye.